All right, let's look at this week's exciting stuff in Python programming. Right. So let's go to Buzz and see what we got here. Foundations of programming. So if we go to our grade screen first off, see that yesterday was the 5.03 assignment, procedural and object-oriented programming. So today is classes and methods that's due this weekend. Classes and methods. And then we got a gap, right? Because next week's spring break. So even though this is due Sunday, I won't be grading it Monday. Hint, hint, But if you're behind, this is a great time to get caught up because after this, we got that week break. So the next thing's not due till April 2nd after that, which is the Module 5 exam. But it will be open. You can take that early if you want to. But hey, this week, this classes and methods assignment, I would get it done as early as I can. I would want my spring break to start as soon as possible. So once you get all your stuff turned in, you're on spring break, right? So anything you're behind, get it turned in. This week's assignment, get it turned in. Let's look at what this looks like. Classes and methods lesson. All right, so looking at that here in Buzz. Starts out talking about the do-it-yourself robot army. Right. Object-oriented programming, which we talked about in the last lesson, OOP, is all about efficiency and control, as are robot armies. You want some control over those, hopefully. So here's a little poem. I'd like to make a robot army. So little Josephine McNee, some large, some small, some yellow-green. I'd make a class so it's less work and change their arms and legs and smirks. I'll add some methods to make some fly, some dance, some sing, and others cry. These robot objects will be my friends, all made from one but different. Oh, wait, what's that? What's that you say? You say I'm programming the wrong way? My robot army says you've been led astray. So I don't know if just little Josephine McNee ever created a robot army, but someone wants to include some poetry in our programming class this week. So we did. Now, you've been working in Python, which means you've been working with object-oriented programming because that's what Python uses. So like most modern programming languages, Python allows you to work with objects that you create. Programs written in OOP can be larger and more complex, but they're still easy to maintain. So think about turtle objects, right? Each time a new turtle is named, a new instance of the turtle class is created. It's given values for its attributes, like the color or the speed you want it to move at, the instructions, which are known as calling methods, to make it move forward, backward, left, right. We did all of that. Objects occur everywhere, like on your cell phone. When you create a new contact, that's a new instance of a contact class. Think of a class like a blueprint for an object. So it gives a template. So because classes often represent real-life objects, like a contact your phone, class names are usually nouns. So it's best practice to capitalize the first letter of each word. So like phone contact, the P and the C capitalized. So let's look how you might create a contact class using Python. So class contact colon. So this defines your class. Using the Python keyword class defines a new class to give it a name. So we're creating the class named contact. So then we initialize it. So once you've defined a class, use the initial init with you got to have the space before it. It looks like two spaces what they put on there, but I think you only have to have one. There's just one over here. And then you have the parentheses, like on this one, they put the word self in parentheses. So you're defining initialize, and that's when they call it self. Once you define the class, you'll use the initialize method to initialize new objects. Every class needs one of these. So when you have a class, you have to create a new object. When you create a new object, the method sets all the initial values of that instance. So let's look at this. Now we've got to set the parameters of self. So the parameter self plays a key role in a class. They are used to reference the object so it can set its attribute values. In this case, the attribute values are blank, right? So they set name and phone. Self.name equals nothing. It's empty. Self.phone is empty. right? So this is setting up to be able to put contacts like in your phone or something. If you're making a list of contacts. Name your instance. Once a class has been written, which you've done right there, you can create instances of the object in your main method. This is similar to creating an instance of Turtle, right? Because we use lots of different Turtle graphics in some of these programs we've done. So like T equals Turtle, parentheses, the same can be done for a contact. New contact equals contact, that's which calls up this class that we've already created. So now we've started the program. Define main, that's when we know your program has started. You've already created this contact class up here. And so to retrieve object values for a contact's object name and phone number, use the dot notation. All right, to do this, write the name of the object followed by a period or dot, and then either an attribute or method. So this lets Python know which instance of an object to use. So here we have, let's look at it. We did the name and the phone, set them blank, define main, new contact using the contact class. So print name, and this was in quotes, so it's going to print exactly that, name colon, plus the new contact dot name, plus a space, that would put a space between there, and then the phone number main, right? Which right now, printing that would be blank because we set it as blank. But as you add contacts in there, then it would have something to print. All right, let's look more about classes and methods. So improving the initializer, right? It needs to initialize when you create a new object. Start with some kind of initial values. So you can improve the initializer method by adding parameters. So previously, the initializer method set the name and phone number of the contact just to empty strings, right? So there wasn't anything in there. What if we could set the name and phone number when we first create the object, which we can. So we can add parameters. So let's look at this again now. Class contact. So this is just a comment. Create a new contact with name and phone number. So define, there's the initialize statement. And in the initialize statement, we're setting the name and the phone as empty strings. Instead of doing it afterwards, we did it as an empty string as part of the initialization. Then when a new contact object is created, the values for the name and the phone attributes can be passed. So self.name equals name, self.phone equals phone. We get into our main part of our program, and now we want to add one. All right, so we're adding a new contact, and we're using that class contact, and we're setting the two values. Monty would be the name, and here is Monty's phone number. So then when we print name and phone, it has these values in it now. So we initialize it to be blank. We said, okay, self.name will be the name. Self.phone will be the phone, which we've given in the initial up here. Name and phone is right there. So now we can start using it. So let's look at some actual programs here. All right. Class contact. Define initial self. And then we did the self.name's nothing. Self.phone's nothing. That's like the first example we had in the last page. And then new contact equals contact. So let's read that, run that program. Nothing happened, right? Because we didn't have any print statement at all. So let's see what happens. So there's a lot going on. A contact class is created. The initializer method's the key, right? Initialize. Got values to name and phone, which are initially nothing. The self parameter first, the new object. Self.name, self.phone. So new contact equals contact, parentheses, creates a new object in the contact class. Excuse me. And the object's name is new contact. So it's a good start, but we don't have anything in there. So let's go to the second example. Same thing up here. But now down here in the main part of the program, new contact equals contact. Okay, so we've got that set up and ready. Print initial value of name, new contact dot name, which should be nothing, right? Because the initial value, we set it as a blank. give the contact a name. So now we said new contact, which we've created right here. New contact. New contact dot name is Monty. So now it knows to assign to the name that we initialized up here, name, set it to Monty, and we can print that. So let's run and see. The initial value is blank because we initially set nothing there. That's an empty one. And then we updated that to be Monty. Right. So when you're writing programs using this, it often helps to come back and just copy this kind of stuff, copy this whole program and play with it. Put it into an idle window, change some things, see how it works, try to understand what changing a value does. All right, let's look at the next one they have here. Now they've moved name up here and phone up here to set it as a blank at the very beginning. And we've got the self.name equals name, self.phone equals phone. And down here, they've added that statement we saw in another example, new contact equals contact Monty number. So again, this phrase here is using this class we created. We created a class called contact. So using that, put this into there as a value. And now print my contacts, name and phone number. So let's run that. There it is. It prints my contacts. Then another line prints name and the name that's entered into there, which is Monty, and the phone number, which is entered right up here, which is right there. So we changed the initializer method. So we put this up in the top as opposed to the last one where we set it the blank ones below that, self.name equals nothing. We've just made it a shorter, more concise thing to put it all in one line. So now we can put this initializing statement down here. Let's look at the last example. So it starts the same way. Put name and phone number in the initializer statement. Go down here. Now we've done two contacts, new contact and new contact 2. So we've got Monty and Dan in there with their phone numbers. And then when we print that, we can print new contact and new contact 2 like this. And then it says update Dan's phone number. So it changes new contact.phone. So it sets a new value. See, we originally set it to this value. And then after we printed it, we updated it. We gave new contact to just the phone portion a new value. We didn't change the name. And then we printed the my updated contacts. So when we look down at the output, we had my contacts and it printed those initial values. And then it updated just the phone number for Dan. Left name. So once you put something in your class, like this being a contact class, you can go and update just pieces of it as needed. All right, let's look at our next page here. It'll take a little practice with that. I say, you'll copy those programs, change things in there, and see what you can do. Adding methods makes your object smarter, gives it more functionality, so it can do more than just create itself. So let's keep working with the contact object, new contact. All right. You want to create something that will store Monty's information like a ringtone. So within the definition of the class, the method play ringtone parentheses is added, and the perimeter itself allows you to access the object's attributes. So define, here we are defining a function for our program, define play ringtone self. So this plays the ringtone assigned to the contact. So if self.ringtone is equal to hello, print hello, it's me. Else print ring ring. Right? So that would mean to make a contact play a ringtone, the method is called for that specific object. New contact dot play ringtone parentheses. So let's test understanding of this. Let's look what they've done with their program. Okay. This is an object-oriented program that we're working with. Again, creating our class called contact, initializing it. This time we've added ringtone to our initial values. First we had name, then phone, and now ringtone. We've set them all to be blank. Right. So now we've gone and done the self statements, self.name, self.phone, and added self.ringtone will be the ringtone, name, phone, and ringtone. So now let's see, defining the function called play ringtone, self. So if self.ringtone equals hello, it's going to print hello, it's me. Else, if it's shake it off, print cause the player is going to play, 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 play. Else, if it's not hello, it's not shake it off, it's single ladies, then print because if you liked, then you should have put a ring on it. Else, just print ring, ring. So it's checking for 3 specific ringtones to see if it's that contact has the ringtone of those 3 song names. Define main. So here's the new contact. We added Monty's phone number, and we've given him the ringtone hello. And then we're going to print that. So new contact, play ringtone. See, play ringtone is this function that we defined right here. So let's run the program. Monty, phone number, hello is his ringtone. And then there you go. There is playing the ringtone because we told it right here. If the ringtone is hello, play hello, it's me. Print that. So we see that right there. Let's move to the next example. Okay, same thing at the beginning. Down here, the same hello, shake it off, single ladies. So our ringtone function is still defined the same way. There's our new contact, Monty. Same thing, hello. Now we've gone down here and we play the ringtone that's set to Monty. And now we're going to change it. New contact dot ringtone, change it to shake it off. And then print this again to see. So let's run the program. First, it did what we did in the last program. Name, phone number, ringtone, and printed out the statement for that ringtone. The lyrics, if you will. Then we went in and changed the ringtone. Still same name, same phone number, but now we've changed his ringtone to shake it off, and we've printed the lyrics for that. Okay, again, so just changing the ringtone after created a contact class. All right, let's look at this last example they give us. Now we've got dues owed, and this is a numeric value. So we just set it equal to 0 instead of blank. Instead of 2 quotes, we use 0 because it's a numeric value. So we've done the self.name, self.phone, self.ringtone, self.dues owed. So now we defined a function for pay dues, self comma money. So compute the dues owed for the club membership. Self.dues owed equals self.dues owed minus money. So anytime they pay something, that comes in as money and they subtract it from what's owed. So here's the main function. So we set the news contact, Monty, his phone number, his ringtone, and he owes $12.50 in dues. So we print his name and phone number, and we print dues owed and that $12.50. It's stored under new contact dot dues owed, and we want to print it as a number, as a string. It's a number, so we print it as a string. Then we process, there's a payment that equals $10. New contact dot pay dues equal payment. Now what's the owe after that? So we'll see how that works. Dues owed now $2.50. So it should print the name, phone number, amount of dues owed, process the payment. Right, new contact dot pays due payment, and now it lowered it by $10 because he paid $10. All right, so let's see what our assignment is this week. Go to the last page, Here is the assignment. Oh, I need to put the template. I'll put the template in the Google Classroom. I haven't added that yet. I'll do that as soon as class is over. So look over the code. Here's what we do. Use the following guidelines to write your program right there. Look over the following code that starts the superhero class instead of a contact class, where this is starting the superhero class. You could use this as your starting point. So this is what you can copy and paste to start your program with. They're giving you the start. Now you are supposed to come up with 2 additional attributes and 1 method to add to the class. All right, so be creative. An attribute could be a motto, a villain, a strength, a weakness, an alter ego, whatever you want to add. And an action, you might define save world or transform hero. Maybe they transform into something different when they do something. So here's your starting code you can use to start your program right here. Class superhero. So superhero class represents the facts that are related to the superhero. Here's the initial value. Name equals blank. Strength points equals 0. So starting out, we don't give them any strength points or name because it's just setting up the class. You're going to fill that with a superhero. So create a new superhero with a name and other attributes. Self-name, self.strength points. So that's the name and strength points. Define add strength points. Self and points. Add points to the superhero strength. So self points equals self points plus whatever points are added on that. So what you're supposed to do is update the class by including at least 2 new attributes and 1 new method. So you're going to add to that. In your main function, create your superhero. That's when you add values to this. Using the examples you just saw in the last 2 pages, is how you would add, like it was adding a contact, you would add a superhero, giving him a name, giving him strength points, giving him whatever other attributes you add, because you have to add 2 more attributes. So be sure to assign values to the attributes and call its methods. Create output that describes your superhero in a story fashion. So you're going to have print statements like, our superhero's name is, and he had to lift a car, but he has this many strength points, or whatever story fashion you want. And don't forget to write the pseudocode. Now, pseudocode, you already got to start right here. So you can put in your pseudocode, use starting program. Maybe that's I'm going to use the starting program. I'm going to add this attribute. I'm going to add this attribute. I'm going to add this method. I'm going to create superhero with this name. I'm going to, whatever your plan is, your pseudocode. And you can modify your pseudocode as you write your program. Oh, I need to go back and put this in my pseudocode because I decided I'm going to add this superhero's name or this thing. So if there's any input calculations or anything, be sure to include that. So you're going to insert your pseudocode, code the program. You can copy and paste the superhero class code above into idle. You don't have to. If you want to start from scratch, you can, but I would take advantage of what they gave you to start. Make sure you have the heading that has your name, date, and short description of your program. That's got to be at the top of every program. Of course, use indentation, white space, meaningful variable names. Here's an example of someone else's output. This is an example for you to look at and say, okay, it kind of lets me know what we're looking for. Their output was, let me tell you about my superhero. Her name is Captain Python, and her superpower is exterminating logic bugs. And when facing the villain's sinister syntax, she shouts out her motto, batteries included, then rushes to save the world. The villain is defeated when he falls into an infinite loop. This heroic action earns her 100 strength points. Captain Python now has 121 points and has saved the day. So that's an example of how someone else put it into story form. You can see they've added a motto as one of their attributes, and a superpower, exterminating logic bugs, the name, Captain Python, and a villain. So the 2 things she added was the villain and the motto. So there's her villain that she fights, is sinister syntax and a motto. So, and then did a little story with that. And then, of course, you have your questions at the end, your post-mortem review that we always do. It's usually worth about 20 points. Let's see how much worth this time. If I look at the rubric that's used to grade this, your design's worth up to 10 points. The content, 40 points. And that's where it has to, the code reflects the pseudocode. That's part of that 40 points. 2 attributes of the method are added. That's part of that 40 points. You have a main function and you create a new object, right, where you're adding the superhero, and you have the correct output telling about it. So all that's worth 40 points. 30 points if it runs correctly with no errors and produces what it's supposed to produce. And then again, 20 points for the post-mortem review. So if you don't do the post-mortem review, you've automatically lost 20 points. So that is this week's assignment, dealing with classes and methods. So always go back to those example programs, run those. If you want to change something in there and see how it affects the outcome, that's a great thing to do because it helps you understand the program. Oh, this line controls that because when I changed it, that's what changed, right? So you can do that. It's great this week that they gave you a starter. So you've got some lines of code to start with. So you just have to add to that. So that's giving you a good head start this week. You don't have to start from scratch. That's great. We like the help. So, all right. Like I said, spring break is next week. So you've actually got 2 weeks. The earlier you get things done, the longer your spring break gets to be, right? So don't wait. If you're behind on some programs, any assignments, get those turned in. And we'll meet again in 2 weeks. For those of you whose grade's below 70, we'll meet again on Wednesday and Friday if your grade stays there. If you get the stuff in, get your grade over 70, you won't have to be here Friday or Wednesday. So, all right. Anyone have any questions? All right. If not, go out there and get your superhero going.